specifically have 45, 30, 60, or sides, specific sides. Well, what if the angle's like 22 degrees or 57.3? Right? Well, what if the angles in a right triangle are different? Can we still find the other sides and angles? And this is how we'll do it. And so the answer is yes. It goes back to what we did on Friday. So remember that little activity we did where we measured the lengths of two triangles that were similar? They were similar because they had two angles the same. And yes, yeah, very good. I said for any triangles in the entire world that you can think of that have 34 and 90 degrees, and then the other one would be, I guess, 56, right? But any two triangles in the world that have a 90 and a 34, the ratio of the height to the base, we know. It's the tangent ratio. Okay? And so because they're similar, they all have, every triangle that in the world that has that has the same ratio. We know what that number is. Okay, mathematicians, we have discovered every number and every ratio that there is, what that ratio would be. And it's an exact number that we know. So that's why on this one, when we did it, it was like 0.67 or something. If you would have just entered tangent 34 in your calculator, it would do 0.67. And so without having, I was showing you how we actually develop it, but if you do tangent 34, you can get it. You might be in the wrong mode, and we'll talk about that tomorrow. So I'll tell you how to get in the right mode tomorrow. Well, actually, press mode, and you'll go to degrees. So let's talk about there are three ratios. Now, they're not going to be height to base anymore. It's going to be based on the opposite, hypotenuse, and adjacent sides. Let's see, anything else I want to say about trigonometry? Trig means triangle, metric, so it's finding all the measurements in a triangle. And guys, what these are, it starts off just doing a ratio. Coming up later, we'll actually find out how to use the ratios to find missing sides and angles. But for now, it's simply a ratio. So I want to really get that in your head, like, it's similarity, based on similar triangles. Everything in trig is based on this. Okay? Any two triangles in the world that have those angles would be similar. Okay, so let's look at the first one. Contrary to popular belief, on your calculator, it is not the sin button. Okay? Sine is the actual name of that. We abbreviate it as SIN. I know, it's a big abbreviation. We dropped off one letter. So we abbreviate sine as SIN, and we pronounce this as sine, not sin. Sine is all these are ratios. I'm going to say trig pretty much from now on instead of trigonometry. That's okay with you?
Yeah.
It's shorter.
Same.
Yeah. So trig, the trig ratio for sine is the opposite leg to the hypotenuse. It's that ratio. Now let me explain. So let's look at this one. It says that we read that as sine of A, not sin A. Sine of A. What this means is go to the angle A. Here's the angle. I'll say it now. For trig, you can never use the right angle. All right, so it has to be a right triangle, but you're never going to do sine of C. You're never going to do sine of the right angle. Right, never going to do that. So what this means is write down the ratio. Go to A. All right, we're right here. Write the ratio that is sine. Now, here's what I like to do. I like to label the sides. There are going to be three sides. The first is the hypotenuse, the side opposite the right angle. Up here, right? So go ahead and label that for me. You can just put like capital H. I sometimes don't do that moving forward. Right now I'm just going to write HYP for hypotenuse. Then we've got the opposite side. So from angle A, opposite would be over here. I'm going to label it as the OPP. Now the leftover side is the side that is not the hypotenuse, but it is next to angle A. It's the B on the bottom here. Next to is adjacent. So we call this one here the ADJ, the adjacent side. Now you might say, isn't the hypotenuse also an adjacent side? It is, but we already have a name for it. That's the HYP, the hypotenuse. So with these three little names, opposite, hypotenuse, and adjacent, we get all three of the ratios. So let's go back here. Sine of A. Go to A and do the sine ratio, which is the opposite over the hypotenuse. So sine here, opposite is little a, hypotenuse is little c. Majority of the time, those are going to be numbers, right? Write the ratio, 3 over 5, 7 over 10. There will be problems where they will leave it in terms of variables, though, and ask you to figure out things about it. So that's what I'm doing now. But they will be numbers moving forward. And that's it. It's a ratio, a number. I'm going to do another one and then tell you about the other two. But any thoughts right now on, that's your first example of sine. It's a ratio. Not too bad right now, right? Just a ratio. So let's do sine of B. That says go to B and do the opposite over hypotenuse. Now when we go to B, the hypotenuse is the hypotenuse, right? That doesn't change. But the opposite side is now going to be down here. Right? The OPP, the side opposite the angle B. And this would now be the adjacent side. I got a lot going on up here. There's a lot to see there. This would now be the adjacent side, right? This side. So now from angle B, opposite is little b, kind of covered it up, and HYP, the hypotenuse, is still C. And that's it. So you can see it does change if you go to the other angle. You can never use the right angle. I think I'll have time to tell you about cosine. Let's do that one to finish up. So cosine, abbreviated COS, still pronounce it as cosine, is the ratio adjacent over hypotenuse. So I'm just going to let me start how it was before. This was the HYP, this was originally the opposite, and this was the adjacent. So, same diagram, it's just now it's the adjacent side over the hypotenuse. The adjacent side is little b, and the hypotenuse is little c. And you'll see when we go up here to angle B then, so I'm on cosine of B, it says go to angle B. Now this one would be the opposite, and this one would be the adjacent. And so now cosine of B adjacent A over hypotenuse C. Let's stop there. I'll tell you tangent tomorrow, and then we'll do a few problems solving for the missing side based on. So.